Lesson 7, insulators, conductors, and others. And some of this is pretty important, and some of it's not so important. So again, we'll sort out the important thing. In conductors, electric charge is able to move very freely. So objects that are good conductors move electricity very easily, like copper wires, for example. All the wiring in your house probably is made out of copper because copper is a really good conductor. Electrons can move through copper very easily. Insulators are materials where electrons don't move so easily through those materials. So for example, rubber, it gives you an example, or lists rubber as an example of an insulator. Okay, semiconductors, yeah, this is interesting. You should read this, and you should watch a video on semiconductors, actually, and you should definitely watch a video on superconductors, because superconductors are amazing things that will revolutionize energy if we can figure out this annoying problem that superconductors need to operate at about minus 200 degrees Celsius. So if you can figure out a way to make superconductors work, in other words, to have superconductivity, which means there's essentially no energy lost in electric transfer, then yeah, you'll be a wealthy person. So, okay, so that's all interesting. Please read that, watch some videos on superconductors. This is important, the reason for conductivity. So some materials, in conductors, the electrons furthest away from the nucleus in the outer levels, the valence electrons, are not attracted as strongly by the nucleus, so they're free to move around, right? And that's why we get conductors. In insulators, the electrons are tightly bound to the nucleus and don't move as freely, and so electric charge or electricity or electrons don't move through those objects as easily, and therefore they tend to be insulators. This is where we're going to start to get into the interest or the really cool stuff about static electricity, and we start off with this term, separation of charge. So in this example right here, I've got a positively charged object, and I've got a neutrally charged object. So I think it's neutral. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, so the overall charge of this is positive 10, and the overall charge of this is 0. But what happens when you bring these two objects close to one another? Because this is positively charged, it's going to attract the electrons from this object, and even though the overall charge of this is 0, these objects are still going to be attracted to one another. So if we're asking the question, can an object that has a charge be attracted to an object that doesn't have a charge? The answer is absolutely, because of the concept of separation of charge. So it just means within that object, all the electrons that are free to move, because this object clearly is a conductor where electrons can move easily, will be attracted to this positively charged rod. The overall charge stays as 0, but now you have opposite charges, and they're going to attract one another. So they're going to attract one another at this end of the object. And that's separation of charge is a very, very important concept. And here's the opposite happening. This time you have a negatively charged rod, and you bring it to a neutral object, and the electrons in the neutral object will be repelled by this object here, and so they will move to the opposite side, and you'll create this situation here, where you have negative and a positive near one another. So those objects will actually be attracted to one another, even though one of them doesn't have an overall charge. It's neutral. And that is it. That's the end of that lesson. It's a fairly short lesson, but we covered all the important things. The most important thing for this lesson is the concept of separation of charge. On to lesson 8.